Hi everyone, my name is Ankit Chopra. This is the project submission for predicting electrical energy output for the course of Machine Learning Foundations for Product Managers by Duke University. Our goal is to create a model to predict electrical output of a combined power cycle plant based on the shared dataset. The approach is as follows. For this project, we are using a supervised learning model for predicting the electrical output because we have past observations of features in the target variables, we have a structured data availability, and we have a numerical target variable, which is the electrical output. As we're predicting a numerical target, which is the electrical output, we will primarily be using regression as a prediction algorithm. We're splitting the given data into two parts: training dataset, which is 80% of the original dataset, and a test dataset, which is 20% of the original dataset. We will be training the model on the training dataset using regression models, and post that we will evaluate the model on the test data set using error metrics. We are using a regression error metric of mean squared error as our primary output metric. We will be evaluating the performance of three models based on different features selected. The first part of the project is evaluating the features and doing feature selection. We ran the correlation between the target variable, electrical output, and individual features, which are temperature, volumes, ambient pressure, and relative humidity. We found that the features temperature and exhaust volume show a high correlation, whereas feature ambient pressure shows a medium correlation, and the feature of relative humidity shows low to medium correlation. In this exercise, we will compare the performance of three models. Electrical output as a function of temperatures and volumes. The second model which will be electrical output as a function of temperature, volume, and ambient pressure. And the third one will be electrical output as a function of temperatures, volumes, ambient pressures, and relative humidity. Using the training dataset and Excel as a tool, the regression algorithm provides us with the prediction functions for the three models which we've been talking about. The first one is the electrical output as a function of temperature and volume. The second one, electrical output as a function of temperature, volume, and ambient pressure. Third one, electrical output as a function of temperature, volumes, ambient pressures, and relative humidity. Once with the three models and their prediction functions ready, we now run these prediction functions or models on our test data set and calculate the mean squared errors and R squared values and compare the results. Based on the comparison of the output metric, we see that the model 3 has the least mean squared error and has the highest R squared value. Therefore, we conclude that the model 3 is the best model for predicting the energy output. This concludes the submission for the project, and thank you very much for listening and happy learning.